Hey, what's up everyone and welcome to Daily Code Buffer. We are starting a new series on system design, and the main idea and the goal about this entire series named Scalable Thinking is to not just get you prepared for your system design interviews, but also to make sure that you learn all the concepts about system design so that you can use those concepts and build this scalable solution as well in your job. So with this series, we are trying to hit two targets with a single arrow, where it will prepare you for your interviews as well, plus it will prepare you for your job as well to build these scalable system designs. So that's why we are calling this series as a scalable thinking. Now within this topic, we are going to cover the basics about each and every algorithm, each and every component that we can use in the system design, and we are also going to go deep dive into each and everything about how we are going to use this, what is the purpose of using it, which all companies and which all technologies are using this, and how to implement this with the help of a code as well. So there are a lot of components that we can actually learn more about by implementing it. So we are trying to implement all those details as well. So we are going to deep dive into each and everything within this series. With this, the first topic that we are going to cover is the consistent hashing. So let's understand about what is consistent hashing, why we use consistent hashing, and how to implement it. So welcome to the series of scalable thinking. Now, before we understand about the consistent hashing, first we need to understand why we need a consistent hashing and why it was introduced. Okay, so let's consider about a simple example where we want to create a simple web application where there is a client which connects to server. Okay, now this is a system that we have built. Now what happens is, as the application grew, right, more and more number of users are coming to your application, we needed more servers to handle a lot of different traffics. So what we did is we created another server 2, and we added one more server 3. Now all the traffic from the different clients C1, C2 can go through different servers, server 3, maybe server 2, and so on, based on the load balancer. Okay, so you will put a load balancer here in between, which will handle all your traffics. Okay, that's how generally we do. Now all your different clients is been served by the different servers for your different requirements. Now the similar kind of requirement we get while storing the data as well, right? As we are working with a database, we store all those different data into database. So suppose let's say a DB here, that this is my DB. Now all this request comes here and I want to store all those data in my database as well. Now just using a single database will not be suffice here, because as we have added multiple servers here and our application is just using single database, it is a single point of failure for us, right? It's a blocker for us if this DB goes down. If there is an issue within this DB, then all those servers connecting to a single DB will not be able to serve the request or serve the traffic. So for that, what we can do is we can do the database sharding, database partitioning. Now all those things, how can we do? We have to do partition the data based on the different requests coming to the different servers based on the hashing algorithm. Okay, so what we will do is, suppose rather what we did, we took this database, okay, and we created 3 more databases. Suppose it's DB1, DB2 and DB3. Okay, and data is coming through all those 3 servers. Okay, so now you can see that I have my database, but I have 3 instances of my database. Okay, now which server should send the request where? Okay, suppose I have 100k users. Okay, 100k users are trying to serve the data or trying to get the data from my servers. Now all these servers has to store the data in each of the database. I have to shard my database. Okay, we will learn about all the shardings and everything in the later part of the video, but just understand that I want to store the data equally within these 3 databases. So how I can do I can store the data into this 3 database for all these 100,000 users by dividing all those data into 3 parts. So if I have 100,000 users, right, I will divide by 3 because I have 3 servers and all those data will be sent to these 3 servers. So 33,000 will send to here, 33,000 will send here, and 33,000 will be sent here. Okay, so now I am dividing the data here. Now suppose user 1, okay, let's take the user 1, user 2 and user 3. There are the 3 users. Okay, now user 1's request went to server 1 and it went to DB1. Okay, so user 1 went to DB1, user 2 went to DB2, and user 3 went to DB3. Okay, so all those 3 requests sent to different users and the data has been sent to different databases. Now we need to make sure that whenever the request comes for the user 1 again, okay, if user 1 is doing the request again, my request should go to DB1 only, because DB1 has the data for my user 1. If it goes to DB2, then it will not be able to get the data, right? Because I have stored my data into my database 1. And if the user 2 is coming, my request should go to DB2 only, and for user 3, my request should go to DB3. Okay, so that's how it should work, because I need to figure out that as I have stored my data for user 1 into database 1, rest all the requests coming to my server should go to database 1 for the user 1. That's what I need to make sure. Okay, how do I make sure? I do make sure using the hashing. So what I will do is, as I have 3 servers, okay, server 1, server 2, server 3, rather let's call this as a DB, right? These are 3 different database servers for us. Okay, so now what I will do is, whenever I get the request, okay, here I can say that n equals to 3, right? Because I have 3 servers now. So now what I will do is, whenever I get a request for user 1, okay, suppose I'm getting a request for user 1. Now for user 1, what I will do is, to make sure that for user 1, all the requests should go to an unique server every time, unique database server every time. What I need to do is, I will do an hashing algorithm on this. So I'll perform an hashing algorithm. So performing an hashing algorithm on the user will give me some input, okay, some value. And with this value, what I will do is, I will do modulo of n. N is the number of servers that I have. If I have 3, I will do modulo by 3. If I have 4, I will do modulo by 4. If I am doing modulo by n, I will get a value either 1, 2 or 3. Okay, S1, S2 or S3. 3 database servers, I will get the value. Now whatever the value I get, I will serve the traffic there. If I get the value 2, I'll serve the traffic there. If I get 3, I will serve the traffic there. Accordingly, I will do. Now this will only be applicable when I have a fixed set of servers. Okay, now if I add a server 3, S4. Okay, so let me just change to S4. So now if I add the server 4, now my n will become n equals to 4. Now if I get value 1 for the user 1, okay, and what I will do the hashing again. I will do that value whatever I get from the value, because we make sure that whenever we do hashing, the value that we get should be same. Then I will do again modulo of n, which is 4. Then I will not get 1 again. I might get something else, right? So what will happen is, if I get something else, is I will be able to go to that particular server and I will not get the data for that user. So now what I'm trying to say is, as I have limited number of servers, with that limited number of servers, when I'm doing hashing and doing modulo operator to identify which server I want to go to, I am not able to perform consistent operation, because I'm not getting the consistent hash value or consistent server value to connect to. Okay, now when this situation occurs, like you are not able to add to that or serve the traffic to the particular server, what you need to do is, whenever you add a new server, whatever the data that you have in the existing servers for server 1, server 2 and server 3, you need to perform rehashing for each and every data existed in that server, right? Because whatever the data is stored in server 1 is stored with the help of hashing modulo by 3. Okay, now as we have added a server or we have removed the server, either of the cases, we have to do the hashing operation on all of this, and then we can add a new node and then start serving the traffic. So you can see that if I have stored 1 million records, okay, I have to do the hashing operation again for all those 1 million records and store against 4 servers again. Okay, so this operation I have to do for all the data which I already have. Now this is not an ideal scenario where we will not be able to do this millions of records available to do rehashing and restoring all the data. So in that case, what we can do is, rather than just having this hashing algorithm approach, we can use the consistent hashing algorithm. Now in consistent hashing algorithm, what will happen is, rather earlier what we were doing is we were creating the array of servers, right? Where n equals to the number of servers. So if we had 3 servers, we'll be creating 3 arrays to just store that which server information we have. Okay. Now what we will do is, in consistent hashing, we will create an array, okay, where n equals to 0 to n equals to n, okay, where n is the number which will change eventually. Okay, so what we will do is we will create a huge set of array, and what we will do is we will connect this two ends. So we will take this end and we will connect to this. So we will create a circular array. So at the end we will end up creating the ring. So it's a ring for us. Okay, so this is what we are going to create, where n equals to 0 equals to n. So both of them will connect to each other. So your ring is created. Okay, now rather than storing your data in an array, we are going to store the data in a circular ring. So now if I have 4 servers, server 1, server 2, server 3 and server 4, what I will do is I will add all those servers within a ring. So I will add server 1 here, I will add server 2 here, I will add server 3 here, and I will add server 4 here. So here you can see that I have added 4 servers here. Okay, now what I will do is I will create this ring. Okay, now whenever the request comes, right, so suppose let's say we got a request for object 1 or request 1. Okay, now what we will do is we will again do the same hashing algorithm here. Here also we did the hashing algorithm. With the hashing algorithm only we kept the 4 servers within a ring. Okay, the same algorithm we will execute on the request that we got, and within this particular request we will get to know that where we can keep. So suppose we understood that the object we are getting is somewhere here. Okay, now we got the object 2. So let's see object 2. This object 2 is somewhere here. Okay, now what will happen is we will go in a clockwise direction. Okay, now what it will happen is, so whatever the request comes, right, that request will be executed by the next server available within the clockwise direction. So this request will be handled by this server, that is server 2. This is server 1, server 3 and server 4. Okay, so this request will be executed by server 2. This request will be executed by server 3. If any of the request comes and hash keeps the object here, then this will be executed by here. Okay, so now you can see that we are executing all those objects and requests with the consistent hashing, where whatever the objects are kept here will be executed by the next set of servers available. Okay, so this is how the consistent hashing will work. Based on a hash algorithm, we will put everything within a ring, and all the requests will also be put within a ring, and we will execute all those requests within the clockwise direction. Okay, now within this there is a drawback as well. So what will happen is, suppose let's create a ring again. Okay, and let's keep 4 servers here. Suppose server 1, server 2, server 3 and server 4. Okay, now we added the hashing algorithm here, and what will happen is, suppose we got the hash here, server 2 here, server 3 here and server 4 here. Okay, so now you can see that we added 4 servers here, and the hashing kept all those data within this one part only. Now you can see that from server 4 to server 1 we have a huge gap, right? Now, so you can see that all the objects coming here within this part has to be handled by server 1 only. So you can see that now server 1 will be getting a lot of load compared to server 2, server 3 and server 4. Okay, this condition is also not ideal, right? So sometimes this will happen where if we are adding a new node of server, or we are removing a node. Suppose we just remove this S2, as S2 was down, right? So what will happen is we remove the S2 here, we remove this S2, and now all the data from here, from S1 to S3 has to be handled by S3 now. Okay, and you can see that the data range got increased for processing a request. So there will be a lot of load in one of the servers. Okay, so this also needs to be handled. Now we need to understand, so we will take this part later, how to handle this. Okay, how to handle this huge sets of data. Now suppose earlier within this particular example we saw that if there was any new servers added, what we had to do is we had to do the rehashing of all the data available on all the servers. Okay, but in case of consistent hashing, what we need to do is, suppose we got this server to be removed. Okay, now what we need to do is, as we know that we just execute the data in the clockwise direction. Okay, what we just need to do is, as this server has been removed, then the data between this server and the previous server, this one, only this much data needs to be rehashed, and all those data should be served by the S3. So now this entire block. Okay, so you can see that every time when we remove or add a server, suppose I am adding a server S5 here. Okay, so what will happen is all the data from this particular position to the previous position, so all those data only needs to be rehashed, so that it can know that all those requests should be handled by S5 compared to S1. Earlier it was served by S1. Now as we added S5, all the data previous to S5 till the previous server has to be handled by S5 server. So only you can see a part of rehashing we are doing, rather than doing a complete rehashing on all the data. Okay, now let's handle this scenario where we have a huge range of data to be handled. So in that case, what we will do is, suppose let's do the consistent hashing again. So this is the ring. Okay, and now let's see, we have server 1, server 2, server 3. Okay, now for these 3 servers, what we have is, suppose we have 3 servers, 1, 2 and 3. Okay, this is S1, this is S2 and this is S3. Okay, now we have added 3 servers, so you can see that we have a huge range of data to be handled. Suppose if this server goes down, then for server 1 or server 3 has a huge ring to handle all those data. So to handle this scenario, what we can do is we can add the virtual servers, or it's also called as a virtual nodes. Okay, so what we will do is we will take any of the server and add the n number of nodes. Suppose we are adding 20 nodes per server. Okay, for this simple scenario, let's add that we are adding 2 nodes per server. Okay, 2 virtual nodes. So for S1 we are adding 2, for S2 we are adding 2, and for S3 we are adding 2. So what will happen is, for S1, suppose we added a 1 node here, so that is S10. We added 1 here, that is S10. We added 1 here as S20. We added 1 here as S21. We added 1 here as S30, and we added 1, suppose here, as S31. So here you can see that for each and every server we added a virtual node as well. So now you can see that your ring is trying to get a complete ring where you have a lot of different servers available. Okay, now for each of these servers available within this node, if the request comes, right, so suppose let's take a request. So request comes here. Okay, so now you can see that With this request, what we do is we do clockwise direction, right? So with this clockwise direction, you can see that we got the virtual node that is S2 of 1, right? So this particular request will be handled by S2. Simple, right? Because we have added this virtual node, so we know that where to handle the request. Now for this request, if the request comes here, so we'll go clockwise direction. We know that it's S30, so this request has to be handled by S3. Same goes with every node. So you can see that now we are dividing the request equally so that all the servers that we have gets the equal amount of request. With this, it will not be an exact amount or very equal amount of request, but moreover, we will be able to distribute load very evenly. Okay, so this how you can see that we are trying to add a lot of virtual nodes for a server that we have, and we are trying to handle the request. So rather than just couple of servers within the nodes, we are adding a lot of servers within the nodes, and all those requests will be handled by the each of the particular servers. So that's how we are trying to build a ring, and in practical this ring will be very huge. Suppose if I take the example that suppose I have 5 nodes or 5 servers available, then in reality what I will do is I will create 100 nodes per server. So in my ring I will be having around 500 virtual nodes, and all the requests coming in will be handled by all those 500 virtual nodes. Okay, so the data will be divided more or equally, so we'll be able to perform all the operations equally, so there will be no huge burden in any one of the servers. So that's the idea behind it. Okay, so that's how you can see that that's how we are trying to build a consistent hashing, where a ring like structure we are going to create. This is something, a data structure we are going to create, and this data structure will hold the data for us within this way, where it will store the servers and the virtual node information. And similarly, whenever there is a request coming in, that request will also be hashed within the same way, and we will get a similar way where we are placing the request, and it will be handled by the next set of server. Okay, so that's how the consistent hashing works. We are going to see the code as well, how we can build the consistent hashing, but this is how the entire structure works. Now when we use the consistent hashing, mainly consistent hashing is used where you want to have the highly scalable system where you do not know how many servers that you have, right? So here you can have n number of servers, you can add n number of servers, and you can remove n number of servers. With this you won't be able to face any issues while implementing this sorts of algorithm. Okay, so when you have high scalability requirement and you want to make sure that all those servers are getting a n number of or equal number of requests, at the time we will use the consistent hashing algorithm to divide the traffic to the particular servers. Now where this algorithm has been mainly used, so generally like creating a CDN system, creating a key value store, databases like Cassandra database, Apache DynamoDB, all those system uses this consistent hashing to make sure that the data has been persisted equally or the data has been partitioned equally within their system. Companies like Google, Uber, all those uses this consistent hashing algorithm to make sure that Google uses for load balancing system to make sure that the load is being divided equally. Uber uses the system to make sure that all those APIs are being hit to the nearest server possible. CDM system uses this type of algorithm to make sure that the CDN data is been served from the nearest server available to the user. So to do all those such kind of operation, consistent hashing has been used widely within the industry. So as a software engineer, you should know that how the consistent hashing works and what are the drawbacks of it and what is the problem that it is trying to solve. So let's go to the code as well and understand that how the consistent hashing works. So what I have done is I've written the code in Java. I will just walk you through that code as well, and then later we will try to understand how to build this as a distributed way as well. So I will share this repository with you as well, so you can go through this code as well, and if you want to implement, you can implement within your system. So here you can see that this is the consistent hashing class that I have created. Now what it does, okay? So here you can see that I have created a consistent hashing class and it takes the number of virtual nodes, okay? So suppose I want to create a consistent hashing algorithm with 100 nodes. So per server I want 100 nodes. That's what simply I want to do, okay? So that's why I'm taking a virtual node. And you can see that couple of things I'm doing. I'm taking an MD5 system to create a hashing for me, and I'm taking an SHA-256. You can take either of the things. There are multiple hashing algorithms available, but I have just kept 2 years, so when you go through the code you just know the difference, like actually how the hashing algorithm will work. Okay, we just need to implement whatever the existing algorithms are there. You do not have to worry about how this hashing will work. You just need to make sure that whatever the hashing that you use, whatever the hashing technique you use, that will give you consistent output, so that the data has been divided across the ring. It should not be like there will be a one hotspot created within the ring. You should be able to move the data evenly within the entire ring. Okay, so this is the normal MD5. You can see that hash function for MD5 and hash function for 256 algorithm. So here you can see that we are doing very simple thing. We are taking a key, and based on that key we are taking the object of a SHA-256 and converting that into a byte array. So this will give us a data into a byte array, and from this byte what we are doing is we are taking the first 4 elements of the array. Okay, so here you can see that 0, 1, 2 and 3. So we are taking the first 4 elements of the array from that byte array, and what we are trying to do is we are making sure that that value is been converted to unsigned integer. Okay, you might get a negative values as well, so we are trying to convert to unsigned integers, and we are shifting it to get a long value. So whatever the values that you are getting when you shift it, so here you can see that we are shifting this value to 8, this value to 16, this value to 24 and this value to none. So at the end we are trying to shift it to 32-bit integer value. Okay, that's what we are trying to get. So at the end, once this entire operation is been performed, so I will add in the repository as well what this entire operation does. So if you go to the readme file, you will get a complete understanding how this works. But eventually understand that this is a hashing algorithm where you will get an integer or long value with which you can map your server. Okay, so with this you are getting a value, and with this value what you will do is you will add a node. So this, you can see this is an add node function, and it's taking a node value, and this node value would be what? A combination of the server and the virtual node. Okay, so server is 1 and the node is 20, so it will be like server 1-20. So that will be your key. So taking that, what it will do is you can see that for each of the virtual nodes. Okay, so for a server, what I need? For a server I need 100 virtual nodes. So that's what it is doing. Okay, so for any server added, it will add the 100 virtual nodes. So you can see that for every virtual node it is trying to get a hash value. This hash value is from here. Okay, so once you get the hash value, what we are doing is we are adding to a ring. What is this ring? This is the ring that we have created. It's a tree map. It's a hash map that we have created which will store key and value. Okay, that's a simple thing that we are doing. Okay, and internally we know that map creates an array list. Okay, so by adding a node, what we do is we create a hash value, and against that hash value we are creating or we are adding a server node. Okay, so if I have 100, so it will be 100 different values to be added within the ring, and all of which will know which node particular it is. Okay, so this entire ring will be created. Once this ring is created, you have a method to remove as well. So remove also works the same way. It will take the node, and what it will do is it will remove all the virtual nodes from the system, because if you do not have the server, there is no point of keeping the virtual nodes to point to the server. So it will remove all those particular from the ring as well. And to get the node, you can see that it's a simple method. What we do is we just take the key here and we check that if ring is not empty, if that particular key whatever we are getting, okay, and if my entire ring, if my entire consistent hashing ring is empty, then there is no point of sending the data. We just send the error. Otherwise what we do is whatever the key that we get, we hash that value, and from that hash what we try to do is we try to get the ceiling entry from the map. So what it will do is it will try to map to a particular next set of value available. So what it will do is if your particular key is coming somewhere here, okay, then the ceiling value you will get it here. Simple. So it will give you the next virtual node available. Okay, so that's what we are trying to do. So it will tell us that okay, whatever my hash value is, based on that hash value what is the next server available, get me that server, and based on that server I will execute my request. That's a simple hashing that we are doing. Okay, and for running it, what we have done is we have created I have created this particular code where it will run the code for me. So here you can see that I have created a consistent hashing where I need 100 servers and I have added 5 servers here. Okay, now for all these 5 servers you can see that I want to do 1 million requests. Okay, now for all this 1 million requests you can see that what I'm doing is I am just looping through this 1 million request and I'm finding a node and I am trying to just increment the value that for which of the particular server is been handling how many number of request. Okay, so at the end of this code I will get to know that out of these 5 servers how many requests was handled by each of the servers. Okay, that's the simple code that I have written. So here you can see that the entire code is completed. So here you can see that it was able to run all the million requests, and at the end you can see that it gets me the data like which particular server has handled how many requests. So you can see that most of the requests have been handled very evenly. It's not like that one of the server is only handling 100 requests and rest of the servers are handling more requests. You can see that more of the same we are getting the even number of data, and we also make sure that we don't give the red zone or the hotspot near to the one of the servers. So eventually data has been consistent. Now let's understand how to make sure that whatever the ring that we created, this ring is not a single point of failure, right? Because if this ring is only running on one server, okay, suppose if this is running on one server and all the requests, all the clients, right, all these clients are coming to here to identify which server to go to, and then all the requests are coming to server 1, server 2, server 3, right? Then if this breaks, then we are not able to serve any traffic, right? So we need to make sure that whatever the consistent ring that we create, that also should not be a single point of failure. We should also make sure that that is replicated, right? So this also we need to do. Now how to do this replication, like to make sure that this consistent hashing is not a single point of failure for our entire system application. Now to do that there are multiple options. One thing is we need to replicate this across all the nodes. So what we can do is, if we have a consistent hashing here and if we have multiple clients, what we can do is, as I have clients C1, C2, C3 and C4, all those requests can go to any of the nodes available. Okay, and that particular node for consistent hashing, suppose I have 3 nodes and 100 servers. So now you can see that I do not have a single point of failure. I have multiple nodes available, and this multiple nodes, so all this traffic will go to here, either here, here or here, and based on that I have the list of different 100 servers and it will send the traffic to any of the servers available. Okay, so now this we need to implement. How do? We do based on the replication. So what we can do is we can do this replication either based on the Kafka, based on the Redis, based on the Zookeeper, anything. Okay, so what we can do is we can make sure that if we do Redis, right, suppose I just want to make sure that I implement Redis. With this Redis, what I can do is whenever I will store the data, okay, so what I will store, as Redis is a distributed system, it will have a different set of different servers available which will store all the information about a different servers available and what is the state of the server. So if I have 4 servers available, then this Redis within the distributed way, it will know the information about how many servers are available, how many virtual nodes are there, and how we can handle the traffic. Okay, so with Redis we can implement this as well. So what we can do is we have the consistent ring created, and what we'll do is whenever there is an add node operation or a remove node, if the server is added or if the server is removed, we will create a event, and that event should be listened by all the different Redis servers, and based on that event it will just create a new hashing ring or it will update the hashing ring. So everyone will have the latest information about the hashing ring, about how many servers and how many nodes are available. This is the one way of doing it, but what will happen in this is that it will be an eventual consistency because we are creating an events. Okay, so events will be created and all of those servers will be reading those events. So eventually all those readings will be consistent, but it might be a case where out of the 4 servers available, one of the server is down and that information is not there in one of the rings. Okay, that can happen, but with Redis we can have the eventual consistency. If the requirement is to do that, we can implement using the Redis. Similarly, we can implement this using the Kafka as well, where rather than using the Redis with a pub/sub model, we can have this Kafka topic created where we can have the producer consumer model, where all of those servers will be a producer as well and a consumer as well, where all of those add nodes and remove nodes requests will be handled. As Kafka is also distributed, it can handle multiple servers to make sure that all of those servers have the latest data available. This also is an eventual consistency. So whenever there is an eventual consistency requirement, we can use this, but it will make sure that you do not have a single point of failure and you have your ring distributed across your multiple systems. So another way is to implement using the gossip protocol. So what gossip protocol will do is, suppose you have this consistent ring. Okay, and within this consistent ring, let's see, we have servers available. So it's server 1, server 2, server 3 and server 4. Okay, now in gossip protocol what will happen is every server will try to gossip with each other. Okay, so it's like, okay, and this gossip, and for gossiping everyone will be elected randomly. So suppose this one is selected S4. Okay, so S1 will try to gossip with someone else. So suppose S1 will try to gossip with S2. Okay, what is your latest update on the consistent ring? So S2 will say that, okay, I have 4 servers available. S4 said, oh, I only have 3 servers available. So what it will do is, as this has the latest data available with the latest timestamp, we can have this algorithm implemented in any way that how to handle that. So as S4 understood that, okay, there is some latest data available which I do not have, then it will pull those data and it will create. So it will pull those data and it will create the new ring for them. Okay. Similarly, it will try to connect with someone else as well, and someone else will try to connect with someone else. So they will keep on gossiping with each other and eventually everyone will have the latest consistent ring available. Now this particular approach is self-healing approach, as you can see that everyone is trying to reach to everyone else and it's trying to get the latest information. But the only drawback of this is it's very slow, because we won't be able to understand, like suppose if all the servers are down, if only S2 has the latest information, and if S3 is trying to connect to S1, S3 is trying to connect to S4, S4 is trying to connect to S1, but no one has yet connected to S2, right? So the latest information will not be available, right? So that's why it is a very slow convergence system. So we will not be able to get the latest information very quickly, similar to what we get in Kafka and Redis model. But this is a very self-healing algorithm where a chattiness will be created between all the servers and we will get the consistency. The next one we can use is using the Zookeeper. So within the Zookeeper, what we can do is, as we know that the role of Zookeeper is to make sure that to manage all the different servers. For Kafka also we have seen that Kafka also uses Zookeeper to maintain all those servers because of its leader election capabilities. So what Zookeeper will do is, Zookeeper will select a leader and based on that leader it will try to give the information to all the different nodes connected to it. So if I have 5 servers, so every time a different leader is elected and it will emit the data to rest of the servers to make sure that all of data is updated. So this is how the continuous leader election and the data transmitted to all the nodes will be happening. So all of those servers will have a strong consistency between all the different nodes. So if you have the requirement about a strong consistency within your system, at the time you can use this consistent hashing with Zookeeper implementation. Okay, so that's how the different ways that you can implement and what are the different advantages of using Zookeeper or using a Redis based or a chatty algorithm. I will show you how you can do using the Kafka and Redis. So if you go to the code here, right, I have created a similar folder structure here. You can see that I have created Redis, and if you see within the Redis util, what I have done is I have just created a Redis source which will have a publish and subscribe methods here, so it will be able to publish and subscribe. But the ideal scenario is, you can see that this is my consistent hashing algorithm. This is very similar to what we have seen earlier. But the only difference here, you can see that whenever you are trying to add a node, so at the time you add the node, what it will do is it will publish the data that, okay, I have added this particular node. And when you remove the node, it will also publish the message that, okay, I have removed the node as well. Okay. So every time there is an update operation happening, it will try to publish the event that, okay, something happened. And all of them, it will also try to subscribe to those updates. Okay, so you can see that you are also trying to subscribe to that update and trying to always understand that, okay, it was an add operation or a remove operation. If it was an add operation, update your ring. It was a remove operation, update your ring and remove the data as well. So eventually you can see that you are embedding the data as well and you're subscribing to the data as well to make sure that your ring is always updated. Similarly, it has been implemented for the Kafka as well, where you are creating a Kafka topics, and based on that Kafka topic, you are doing the same operation for updating and deleting the nodes. So you can see that how simple it is to implement consistent hashing within your system, but how powerful an algorithm it is, right? You can see that it's been used by many of the companies to make sure that they are able to serve the traffics very evenly throughout their servers. So that's been it in this video regarding the consistent hashing. So make sure that you understand this particular consistent hashing algorithm and you understand how it's been implemented as well. This will not be asked within your interview how to implement consistent hashing algorithm, but you should know how the internal working is and how that particular thing works, so that you have a deeper understanding about how you can tweak it as well based on your requirement within your job profile as well. So that's been it. If you have liked this video, give us a thumbs up and subscribe to my channel for the upcoming videos. You can also click on join button to join my channel and support me. Share this video with your friends and colleagues who wanted to understand about the consistent hashing and who can get help from this kind of videos. I'll keep posting new videos regarding the system design and how you can improve your knowledge on system design and implement a really better system using the scalable thinking. So that's been, I will see you in the next video. Till then, happy coding. Bye bye.